Okay, so let's start recording. Okay, so week two, and last week we started having a look at Houdini and what you can do inside Houdini, but well, the basics anyway. So we're going to expand your knowledge on procedural geometry, right? So again, a quick reminder with regards to your assessment, you are revisualizing or reimagining a kinetic sculpture. Any one of those kinetic sculptures. So I know that Rafek Anadol created a lot of them. You just need to choose one that's really interesting for you. Have your own creative interpretation for that particular, I guess. Um, so let me just close some of the windows I have here, guys. So again, creative interpretation of one of your favorite ones, and then again explore and find new creative forms and methods to visualize what it is you're trying to visualize. So just take note of that. Okay, so I think it's clear what you need to do for the first assessment. It's just one. So make sure you start thinking about those things, right? Now, before we continue, just quick check if anyone has any questions. I already sent you guys some links, and a lot of them are quite doable. But again, it's really you guys exploring some possibilities. Okay, so I like that idea, for example. Okay, so before we continue, anyone with any questions or concerns at this stage? So if you are ready to go, just a quick thumbs up with everyone, from everyone, and then we can have a start. Well, we can start looking at a few other things with regards to procedural effects. So you guys are fine, no questions. Okay, great. Okay, so everyone's good to go. We can start having a look at some of the stuff here, right? So what I want you guys to do for your second challenge is something like this. So basically, if you have a look, and then we want to render this at a higher level, at a better level. So you're going to create, or the challenge for this week is going to be recreating this particular sculpture. So notice that we have wireframing in the core of it. And then from some of the points there, you start seeing some squiggly lines, almost like a tentacle shape, almost like a virus, really. But on top of that, it's not as easy as you might think. So notice that the base of each of those tentacles are illuminated and has different colors. And then the tip is slightly bigger than the base, and you can actually see it taper and change sizes, as it progresses. And you can actually see that the tips are more illuminated, right? And then it's also moving in a really, I guess, tentacle-like manner. Okay, so you're creating something like this. A lot of ways you can do this. You can use it using the techniques we covered last week, but we'll cover additional techniques today so you can find other solutions for creating this type of stuff. Now, if you've done a lot of 3D already, you discover that there's more than one way to recreate something. So I'm not in any way specifying a particular solution for a creative problem, but it's really developing your, I guess, approach and your, I guess, problem solving skills. Okay, so let's have a look at a few other ways of generating geometry. So we started having a look at things like um, you know um, manipulating groups and attributes to create different types of geometry. We'll have a look at a few other things. Okay, first off is we'll have a look at merge and booleans, which is going to be quite useful for you guys. We're going to do some instancing and copy objects to points and generate geometry through that. And we'll also have a look at what you can do with the lines. So maybe those three things. Now on top of that, we're having a look at how you can render stuff properly inside Houdini using something like karma rendering. Okay, so let's have a look at the first one, which is simple merging and booleans. In fact, it's primarily just merging. Okay, so I'm inside Houdini, guys, and I think I already have everything recorded, so that's good. Uh, so you will have access to that. Anyway, let's start with something simple like merging. And again, most of the time, again, with 3D software, you always want to set projects, right? So remember, when you're in Houdini, just go File, set a project, or set a recent one. I'll set a project, and I'll just go to my, let's say, Houdini projects, and I'll just go My Houdini. And you know what? I'll just use this. Okay, and I'll hit accept. So again, it's always project based, right? Then again, what I like doing is this is your default view, but I sometimes like changing this. So don't panic or you know, um, don't be surprised if my display is different from yours. I simply went and changed my display here or pressing D. and I just went in and then removed my background or changed my background to dark and then turn off my grid. Here under grid, turn off orthogrid. Now you don't have to do it. I'm just showing you guys that because sometimes it's easier to have it like this. So I'll just save that as the default. And again, what I like doing is you really just primarily need that network box or network view. So I like turning off that parameters. Okay, so basically I have something like this. Okay, so it's just two windows, so I don't have to worry about too many windows. Okay, so simple merging, guys. Okay, let's start with something like very simple merging. I'm going to create a box and I'll place it inside my perspective view. So box is a piece of geometry, right? I'm currently in object level and I can see my properties of parameters of my box there. But if you double click on that, you go to your geometry level, right? So relatively straightforward stuff. Now the thing is, yes, that's a box and you can manipulate that box. But the thing is, you can also combine geometry together within that particular context. And what I'll do is inside my geometry context, I'm going to add a sphere. It doesn't have to be a sphere. It can be anything, right? So I'll just add a sphere. Now, again, this is where a lot of you get confused because we created a sphere, but we're only seeing the box. And the reason why we're only seeing the box is because the box is visible. Basically, the display flag is on. But if you have this turned on, notice now we start seeing the sphere. We still see a bounding box of the box, but see, we're primarily viewing the sphere. So what I can do is with the sphere selected there, I'll just move it to the side. And now again, notice what happens. We have the box, blue, and then we have the sphere. Okay, so again, box, and then we have the sphere there. Okay, so what I can do is I can merge them together simply by looking for a special node. Again, geometry level, guys. Under geometry level, we're looking for merge. Okay, and if I plug in merge, we're able to merge multiple objects together. Not just one, multiple. So I'll just select 1 and 2. And then again, you look at it, nothing happens because you haven't turned on the visibility flag. So turn on the visibility flag, and now you're seeing both of them. Okay, now again, it doesn't have to be 2. I already showed you guys that you can add, let's say, something like a test geometry, and then I'll plug in, let's say, this pig head, and then this pig head, I'll just reposition that, maybe make that visible, and then reposition that pig head towards the top there. So I'll modify that, maybe translation there. And then again, we have our merge, and then we have our pig head there. So if you want to do another merge, I can just do another merge here and then merge it with that. Or you know what? Don't even have to. You can just merge it directly there, and notice what happens. We have that merged. Now there is an error there, or a flag, or a warning, but it's not really a big deal. And if you just click on that, it's basically telling you that some of the attributes are not matched, and primarily because this has color, the rest don't, or materials, but the rest don't. But it's no big deal. Okay, so it's relatively straightforward, right? Merging. Again, multiple objects, we can merge things together. Okay, and you end up using that quite a lot later on in the process. So is that clear for everyone in terms of what merging is? So quick thumbs up if it's clear. Merging is quite important, right? Because you are able to merge multiple objects into the same network, and it creates various effects for you guys. Okay, so relatively straightforward. Something that's related to merging, though, is this process of booleans. Boolean is basically just merging, but it has additional, possibilities for you. And again, I remove the merge. I do have a sphere there and I have a box. If you press tab and look for boolean, notice that you have the ability to do a boolean. And basically that boolean allows you to do other things. So notice that it allows you to change your operation. So you can do things like subtract, intersect, you have union, and you have other things there. So let's see. So if let's say, subtract the box with the sphere, and then view that, notice what happens. We don't really see anything. And that's because we don't really see any, I guess, intersection. Let's have them intersect first. Okay, so what I mean by that, let's have this box and the sphere intersect. So the way to do that, perhaps if you just want it visible, I can turn on the template view here, and then I can just manipulate this using this manipulator button, and I can just move this towards the middle of it. And then maybe I'll make this a bit smaller. Okay, so what I have is a bigger box and a smaller sphere. Okay, and let's see what happens if we, I guess, boolean them together. Okay, notice what happens, guys. We have the box being subtracted, subtracted by the sphere. Okay, so the reason why this is happening is it's doing a boolean, and some of you already used a boolean in, let's say, other applications, but this has a more, I guess, procedural way of approaching things. But the idea behind this is we're just doing a subtract. And again, highly impractical for us guys to talk about every single one of these parameters. Takes us forever, right? But the idea behind this is you're subtracting one object using another object. So A, which is your A input, minus the B, which is your B input. That's totally different from something like this. So for example, if my sphere is here and then my box is there. So that's totally different, right? So notice that, see, we're getting this now, okay? Because we're subtracting the sphere with the box, so we're getting that. That's totally different from doing a subtraction between the box and the sphere. And now notice now that we have something like this, okay? Now that's subtraction, guys. There's union as well. So basically combining both, well, you're not really merging, but you're just creating a union between those two objects. And I think you have intersection as well. And if you have intersection, it's basically just giving you the intersection between those two overlapping geometries. Okay, now this one, you won't really use this too much, I guess, for this particular assessment, but might be useful for other things later on in the process. In fact, we'll be primarily using volumes when we're doing this type of operations, and we'll talk about that next week. But is our booleans relatively straightforward, a different way of merging things. So just press tab, look for boolean, and you have the ability to do things like, you know, subtraction and then other things there. Okay, so does that make sense for everyone here in terms of merging and booleans? Does it, anyone with any questions? Relatively straightforward stuff, right? So we are able to do those merging and those booleans. Okay. In fact, we can even do object merges, but I'll probably skip that for now. I'll just do really simple stuff. And then we'll cover more advanced stuff as we move along. But merging for you guys should be relatively straightforward. One important thing to understand when you're doing merging, okay? And let me just, I guess, demonstrate this. Okay, we're still inside that object, right? I have, let's say, a sphere. And I have, let's say, a box. Okay? So I have a sphere, I have a box. And maybe I'll just move that box somewhere to the side. And I'll just use this manipulator to move that perhaps somewhere there. And we do the merge. Okay? Understand that you now have two streams of objects, right? You have the object stream, the sphere stream, and you have the box stream. So what this means? This means if you have things like color, okay? So let's say attribute adjust color to the sphere and maybe add something like noise there. Notice that we're adding a noise color on the individual points of that. But notice that, see, when they're merged together, you have this one colored and you have this one as well. What this means, guys, is you can do stuff in one stream and then do stuff on the other stream. And then when they merge, it respects everything you did to it. And just to prove my point, if let's say with the box, I'll just add some divisions. Let's say 6, 6, it's 6. And then for this one, I'll make this a bit, I guess, longer. And then let's add something like a mountain node on top of that. So mountain node. So whatever it is you do, right? So see, we're adding a mountain node, and then we're even animating that mountain node. And then when we're merging it together, notice that we're just getting an obvious effect there. See? So whatever you merge there is automatically merged with whatever you do here. So whatever you do in one stream and whatever you do in another stream, it will respect that. Okay? So just an important thing, I guess. Okay, so we've covered simple merging. We know how to merge simple objects. And then let's have a look at another thing. Okay, so next thing we'll have a look at, guys, are copy to points. And I think most of you probably worked with copy to points already, but the idea is simple. Okay, so let's have a look at a very simple, I guess, application of copy to points. Okay, I'm going to create a grid because that's relatively straightforward. I'll go inside the grid and go to geometry level. So if you have a look at the grid, guys, you already know, right? At the default, if you middle mouse click, you have point attributes, and even you have face components or primitives, and you even have points. So normally it has points and normally it has primitives, okay? But with the points, you can do a lot of things with it. So I'll just show you. You can actually copy geometry onto those individual points. So if I go here and change this to points so I can see the points, or you know what, to avoid confusion, I'll just turn on points here this way. So I'll just activate the points so I can see them. And basically you end up with the series of points here. So for every single point there, they will have a position attribute. So specified by P, so X, Y, and Z. And again, geometry spreadsheet, every single point has position X, Y, and Z, right? So Houdini takes note of where they are in 3D space. And what this means is you can copy objects to those individual points. And just to prove my point, if I, for example, create a sphere, okay? So again, I'm inside my geometry level. I have my sphere, I have my grid, okay? So let's say I want to copy the sphere, and maybe I'll make this smaller. So I want to copy that sphere to all of those individual points. So every single point, I want to not really replace, but I want to place a sphere on them. So what I can do is I can take this as my points. That's my grid. I want to copy the sphere onto those individual points. I'm going to need a special node, guys, inside Houdini called copy to points. There you go. Okay? So copy to points requires two inputs, right? First input, it requires geometry to copy. So what I'll do, connect it there. Second input is the points to copy to. Okay? So these are the points you want to copy to, right? And notice what happens if, again, that's not the, say, you look at it and it's not working. And again, the reason why it's not working is you're not viewing the correct thing. You have to make this one visible. So turn on the render flag, and now you're seeing that. In fact, let me just turn off the points so you can see them. Okay? So what are we essentially doing, guys? We're essentially replacing, right? Not really replacing. I can say it's replacing, but you're not replacing it. It's still there. But what you're doing is for every single point in the grid, it's creating a copy or an instance of the sphere and placing it into those points. So now you have something like this. Okay? So is the basic concept of copy to points clear for everyone? Again, it requires two inputs, right? First input is the geometry you want to copy. Second input is the points you want to copy to. And then you have something like that. So relatively straightforward. Now the thing is, if you deform this, let's say you add a mountain node. Okay, so whatever you do to the points, what's happening, guys, is the objects here, it's going to inherit the attributes of your points. What do I mean by attributes? Remember, with your grid, and I'm viewing the grid, if you add something like a mountain node with that grid, it's going to obviously animate, and I'll turn on animation and maybe turn on my real-time toggle and maybe increase my amplitude. Okay, so basically if I hit play, I have something like that. Okay, and the reason why you have something like that is it's manipulating the position attributes of your individual points, particularly position Y, right? So what do I mean by inheriting the attributes? The positions, the sphere here that you're instancing or duplicating, it's also going to grab the positional attributes of the points. And what happens is you have something like this now. So if you hit play, notice now that we have the object moving in 3D space as well. Again, it's not because you're animating it. It's really just inheriting the attributes of your points. Basically, your points has animated positions. It's really just inheriting that. Okay? So that's why you're getting that type of effect. Okay? Now, it's not only the position. And let me just show you what I mean. Okay? So it's not only the position. Remember what we did with the grid. Remember that we increased it. You know what? I'll just undo this. There you go. Okay. So remember what we did with the grid last week, right? We increased the number of points there. And then we even added something like an attribute adjust color. So attribute adjust color. And then we assigned, you know, either a noise or maybe I'll assign, let's say, a radial. Okay, so again, what's happening is if you middle mouse click on that, guys, notice that, see, for every single point, there's going to be a CD attribute. And again, if you don't believe me, geometry spreadsheet, it does have a CD attribute. Okay, now what happens is if you have a look at, let's say, doing a copy to points, see, with these as your points, and then with this as the objects you want to copy, notice what happens. See, it's inheriting the attributes of the points. Okay, see, notice that the sphere itself doesn't have any color. You can actually see that, right? There's no color on the sphere. But the moment you do a copy to points, it's inheriting. And the reason why it's inheriting is because everything here is activated. So it's basically just copying those attributes onto those individual objects there. And now you have something like that. Now, needless to say, if this is animated, let's say you use something like, I don't know, noise, and then you animated the noise, and then you hit play. Notice that, see, you're actually getting that particular effect. Okay? So is this clear, I guess, for everyone in terms of what this allows you to do? It allows you to do some really interesting things, right? So it's able to create some really interesting effects. Now, one thing though, okay? Something that Houdini understands, it's an attribute. The attribute is called p-scale. And p-scale is basically the scaling of individual points. So if you have a look at the grid here, guys, notice that it has position and then we added color there. But we can actually add an attribute called p-scale, and p-scale is something Houdini understands. Now, not all attribute is going to be something Houdini understands. So just to show you guys, if I'm going to create an attribute, right? So I can technically create my own attribute. I'll call it attribute create, and I'll call this, let's say, van. Okay? So I created an attribute van, and it's an attribute for the points, and it's a float. And you can actually see that there's a van attribute there. Okay? Just because I created an attribute, it doesn't mean that Houdini understands what it is. I haven't specified what it is. It is an attribute, but it's not telling Houdini what it's supposed to control. But p-scale. P-scale is something Houdini understands. P-scale is something Houdini automatically knows as something you manipulate the scale of the positions for. So let me just show you what I mean by that. Okay? So if I add a p-scale attribute, okay? Let's say I use an attribute adjust float. So attribute adjust floats not only creates an attribute, it also allows you to manipulate the attribute. So attribute adjust float. And the attribute is called p-scale. And then we can make, for example, add a noise there. Okay? So basically, the maximum value is 0, minimum value of 1. So we created an attribute called p-scale, guys. And if you have a look, see, we have a p-scale. It goes from 1 to 0. And then what we do is, if that's something Houdini understands automatically as the scaling of those individual points. So notice what happens if I do this. See? Some points or some duplicates or some instances are big, some of them are small. And the reason some of them are small is because they're using a p-scale parameter that is small. So see? So 0.137, it's using a p-scale of 0.004, meaning that particular duplicate or that particular instance will be very small because we specified, well, because it happened to have that p-scale value. Let's look for something big. So see, guys, 0.72 is big. It's almost 1 because, again, the noise function gave it that particular value. Okay, because we used a noise function. So what does this mean? See, guys, I can manipulate that p-scale. I can make it bigger, or I can make the starting point big. I can, for example, change, I can animate that, okay? And maybe change the element size. And maybe, you know what, change the distribution as well. Okay, so let's see what that looks like. If I hit play, now I guess I get something like that. Okay, there you go. That's right. So really easy to do inside Houdini, quite hard to do inside. Well, it is possible inside Maya, but it's not really Maya's thing, right? So notice that I am able to do, you know, stuff like that. I can make this 0, so I can have something like that. Okay, so there you go. So some really interesting stuff. That's right. Okay, so notice now that we have, I guess, something like this. Now again, we're using simplex noise, and this is where you need to explore, right? Because we don't have enough time to talk about every single noise there. Noise in itself is a topic that you really want to explore because there's different types of noises. But if you have a look at, let's say, whirly noise, you get something totally different from something like a cellular noise, which gives you, I guess, something like that. Okay, now play around with this. So see, if I do that, it gives you something different. And if I do something like this, and maybe something like that, and maybe something like that, see, it gives me different types of effects. Okay. So guys, looks like we might have an issue with my connection. Okay, so it looks like we had an issue with my connection. Not sure what happened there, but hopefully it's still recording. So it is recording, guys. So I'm just checking my other recorder. So everything is recording. Okay. So we are able to just add that in. Guys, it's not only p-scale. Remember, another attribute that Houdini understands is so let me just remove that, is alpha. Remember? So if I just, for example, look for attribute adjust alpha, or attribute adjust so attribute adjust float, okay? And then I won't use p-scale, I'll use alpha with a capital A. Again, Houdini understands that. Houdini understands that with alpha, it's basically the opacity or the visibility of those individual points. So see, I have something like that, right? So what I can do is I can add, let's say, something like a noise, a simplex noise, maybe animate that, and then let's see, and Perlin and an amplitude of 1, and then I'll add a remap of that. So it's controlling visibility now, and it's animated. So let's see what that looks like. Okay, so see, it might be confusing, but basically your object is also a bit specular. So it's still getting the specularity, but it's when you render it out, it's actually gone, right? It's actually invisible. So you have something like that. Again, the reason why this works is because alpha is an attribute Houdini understands. Okay, so I can't really stress that enough. If it's an attribute that Houdini, so for example, if you type in visibility here, Houdini doesn't understand that, so it doesn't know what that does. So if I type in visibility here, you guys see, nothing happens because Houdini doesn't understand that. We're changing the color, but we're not really changing the visibility. Okay? Because visibility is not an attribute Houdini understands. Alpha is an attribute Houdini understands. It knows it's the apparent visibility of those points. And see, now we're able to create the correct effect. Okay? Okay, so is this idea of copy to points clear for everyone at this stage? So is that making sense? Any questions for copy to points? So making sense for everyone. Okay. So copy to points, making sense. Now, an important thing here to understand, guys, and maybe I'll just change this and maybe do an attribute adjust color. This is, again, the idea that Houdini is non-destructive and it's all procedural in nature. Meaning, guys, for example, let me just change this and maybe let's just animate this. Okay, there you go. Okay, maybe I'll just... there are templates here for some of you who are interested. So if I click on these templates, I can have, let's say, an Inferno effect. And again, with that Inferno effect, it just changes the ramp rate gradient. So let's say I'll have in magma, or maybe, I don't know, black to orange, or maybe plasma. No, you know what? Inferno is good. So see, if I hit play, I get something like that. Okay. So what do I mean by this? What I mean, guys, is because it's procedural and non-destructive. What you can also modify this part of the stream, right? So for example, the sphere itself, I can change that to, let's say, a polygon and maybe increase the number of divisions, let's say 30. And then I'll add, let's say, I don't know, a mountain node on this. So basically what's happening is we're adding a mountain node deforming that object. And then we even animate that mountain node. So it's going to go something like that. So if I hit, for example, the merge visibility, see guys, does exactly the same thing. Now everything will behave in exactly the same way. We have other ways to manipulate that, but see guys, now I have, I guess, something like that. We can modify it differently, but it's a bit more advanced. But for the meantime, what the important takeaway is you have the ability to manipulate both parts of the stream, right? This stream and then this stream. And it creates various types of effects. Okay, so we're close to getting things covered, right? So we covered a few things already. We know merge, we know booleans, we know instancing, and we know copy to points. So relatively clear so far in terms of what you're able to do with regards to that. Any questions? You guys are fine? Let's have a look at lines this time. So because, let's see. Um, so you know copy to points, you know how to modify instances and the points themselves. Um, let's have a look at maybe another one. Okay, and that's lines and paths. So another way of generating geometry, guys. So lines and paths. Lots of ways you can do this. Let's just do a very simple one. And an easy way to create a line is to just click on this button here. Or you know what? I'll do this one first, and then we'll have a look at other ways you can create lines. But see, guys, I have a line here, right? So I click on line and then click on enter. Okay, I'll go inside the line, and basically you just have a line node there. Okay, that line node, guys, is specified to be polygons, but you can increase, let's say, the length of that, and you can change what the direction of it is. So currently it's pointing the positive one axis or the positive y. So this is x, y, z, but you can change that to, let's say, point towards, I don't know, x, for example. So see, now it's pointing towards the x-axis where you can see there. But I'll just stick to, let's say, the one in y. Okay, so relatively straightforward stuff. Now, it's relatively straightforward what this allows you to do, guys. It's basically a line. The problem you have with lines is it's not renderable. Okay, so again, the problem you have with lines is it's not renderable. It looks like it's renderable, but it's not. Okay, so you have to be able to convert them into polygons. And the easy way to convert that to polygons or a geometry is to use something like a polywire. So there's something there called polywire. Again, I'm in geometry level, there's polywire. And I plug that in. Okay, and notice what happens with that polywire. It has wire radius. It's basically the radius of the wire. It has, let's say, additional divisions, so you can make it rounder. And then it has segments to just increase the number of subdivisions you're getting there. Okay, and then other things as well, but that's really the basic part, the basic, I guess, parameters of that. Okay, so polywire, really useful. So again, I'll look for polywire. It allows us to convert, not really convert, but use a curve and then have that transformed into or converted into a piece of geometry that we can actually render out. Okay, so relatively straightforward stuff, right? We have a line and we just created a wireframe out of that. Okay, so what, needless to say, since the line in itself is, you know, is a piece, it's technically a piece of geometry as it's an object. So what you're able to do with that line is, so for example, you have something like a grid. So needless to say, right? And then with that grid, you can simply do a copy to points. Then obviously you can copy that line to those individual points there. Okay, so again, this is our grid, right? And then from our grid, we're able to copy those lines. Now, the only issue you have currently is that the lines are pointing in a really weird manner. See, it's pointing towards that. It doesn't really know where it's pointing at, right? So a couple of ways there, guys, that you can modify this, okay? You can modify the line itself. Notice that the direction of the line is y. Maybe let's change that, make it 0, and maybe have that 1 in z, okay? So now it's pointing towards z. So at the without doing anything here, it's using the z direction of the object to properly, I guess, position or orient it in those individual points. Remember, this is our grid, right? And the grid has individual points. But Houdini doesn't really necessarily know how to orient that line on every single point. So the default it did was to just orient it like this. So remember, see, which is weird. So a couple of things you can do here. What you can do is you can just change the copy to points. Sorry, not the copy to points, but the line itself. So instead of facing, let's say, the y-axis, it's now pointing towards the z-axis. So it's pointing something like that. And then when you do a copy to points, it's able to do stuff like that. Okay. Now, needless to say, you can do the polywire after or before. I prefer to do it after. Okay, because this is, again, technically easier and more, well, it's more efficient, I guess, later on the process if you do it this way. So notice now that I can again change the polywire and then modify, let's say, things like divisions and then segments. Okay. So is this concept of lines relatively straightforward for everyone? It again, the line in itself, um, you're able to generate, but to be able to convert that to polygons, you might need a polywire, right? To be able to convert that to polygons. Okay, so let's take this knowledge a step further. Okay, so everyone's good with that. You know how to create lines, and then you can create a polywire. You can draw lines, but drawing is a bit more manual. So I'm trying to skip on topics that require you to do, manual modeling and manipulation. Center the object. It's spacebar F. So for example, if you have, let's say, this line here, right? And you want to focus in on that, select that line, and then spacebar F, and it focuses on that object. So spacebar F. I think you can press F, but I don't think F works. So it's spacebar F to frame that object. So select the node first. Let's say the grid. Okay, you want to view the grid, frame it, select the node, spacebar F, and then it focuses on that particular object. Okay. Okay, so this one's clear. Now let's just take your knowledge of the line a bit further because there's a lot of things you can do with the line. Okay, so let me just show you what I mean, guys. Okay, so this is our line, and let me just go back and change this to, let's say, 1 in Y. Okay, by default, guys, we have a few issues with the line, right? So whatever line you create, not whatever line, but this particular line, yes, you can change the length, but you can also change the number of points there. Okay, so notice that you are able to change the number of points. So what I can do is I can just activate points, and then you can see the points there. If I increase it, see guys, you have additional points there. It's not visible, but you can actually see the points there, right? It's those blue dots there. But that's not even the power of that. So if you increase the number of points, you are able to see the points there. So see, we have position X, position Y, position Z. So we have 10, 12 points, well, 13, but now you're able to see those individual points and their position in 3D space. Okay, so that's good. So see, notice that the more increase, the additional points it actually generates. So relatively straightforward stuff. But that's not even what I want to do, because you're able to modify and manipulate this line quite effectively. Okay, I'll show you what I mean. So for example, with this line, guys, okay, I'm going to resample it, meaning I'm going to recreate this line and add additional attributes to it. So what do I mean by that? So with this line, I'm going to create a resample node. Okay, the resample node is interesting because it's able to add additional attributes that Houdini understands into those individual points. So let me just show you what I mean. Resample. Okay, so with the resample node, notice what happens. This is our original line. We only have 2 points because we specified 2 points there. But if you have resample, we now resampled it to multiple points. And basically what it's doing is it's just creating additional segments based off this length. If you increase that length, then notice that it's just changing the distance between. Basically, it's subdividing it into different segments, and that segment length is around 0.5 or whatever you specify here. Okay, but you can also change this and use maximum segments where you just increase the number of segments directly here. Okay, so see guys, see, the moment you increase segments, you're just increasing the number of points there. Okay, so relatively straightforward stuff, right? You're able to add more points. One interesting thing here, though, is now you can actually generate additional attributes onto those points. So what do I mean by that? See, guys, with your curve view attribute, okay, so notice that we only have 2 attributes here, right? Well, 1 attribute, that's the position. See, position. But with this resample node, we can add an additional attribute there. There's distance, there's tangents, etc. I'm interested with this curve U, okay? So let's turn on curve U. Notice what happens, guys. We have a curve view attribute now. The curve view attribute goes from 0 to 1, meaning the starting point of your curve is 0, the end point of your curve is 1. And let's just demonstrate that. So point 0 has a curve view attribute of 0. Point 29 has a curve view attribute of 1. Let's have a look at that in our scene. So let's look for curve point 0. So see, guys, point 0, this one. So again, I'll just activate points, point 0. Point 0 has a curve view attribute. Just turn that off. So again, curve view attribute of 0. And let's look for point 29. Point 29, all the way here, has a curve view attribute of 1. So it increases, right, from the start to the end. Why is this important? Because you can manipulate this particular curve now. Okay, so what do I mean by that? For example, I can add a color node, and that allows us to add a color onto those individual points. So maybe attribute adjust color. So attribute adjust color, and then maybe I'll add, let's say, a noise color there. Okay, so basically, guys, it's adding a noise color, so CDR, CD green, and CD blue, onto those individual points, right? Because again, we're creating or adjusting or creating a color attribute for every single point there, and then we made it a noise function, similar to what we do with typical objects. Okay, so that's relatively straightforward, right? Now, the good thing about this though is we don't necessarily need the noise. Okay, I can actually use an attribute to control the color. So what do I mean by that? I'll change the noise. I can actually remap an attribute, meaning I'll use an existing attribute to modify the color of that object. So what does this mean, guys? If I use a remap attribute, okay, I'm going to use an attribute that we already have. Remember, we have a curve view attribute that allows us to specify the start of the curve and the end of the curve. What we're doing is we're going to use that attribute to control our color. So I'm going to use curve view. Sometimes you don't see it, sometimes you do, but if you click on this button, it allows you to perhaps use that particular, or you don't have to type it in, but if it's there, sometimes it is there, sometimes it's not, but if it's not, you have to type it in. So basically, you know it's curve view, right? Or you can just plug it in here, curve view. So what we're doing, guys, is see, notice now, with that changed, we have the ramp here with your curve view 0. So this is 0 and this is 1. So if it's 0, it's blue. If it's red, it's 1. So if its curve view is 1, it's using red. In fact, let me just change this to something like, let's use grayscale. So see, guys, it starts off black. In fact, instead of black, let's have it start green, or sorry, red, and then change to blue at the end. Okay, so there you go. So see, guys, it starts off, you know what, to really see this, let's change it to green in the middle. So what's happening is it goes green, then goes blue, and then goes red. Okay, so there you go. So do you guys get why this is happening? This is happening because we grab the curve view attribute, right? We change this to remap attribute. We grab the curve view attribute. Remember, curve view, the start here is 0, the end is 1, and basically it's increasing. So your curve view is increasing from the base of the curve to the tip of the curve. And what happens is we're remapping that attribute. We're using that attribute to create our color effect. So the start of the curve, which is curve view, is 0. So remember, when curve view is 0, it has red. You can actually see that. If curve view is 1, basically the tip of the curve, it's basically blue. So you can actually see it's 0, 0, blue there. And then what's happened in the middle, so see, the next curve view, it's increasing. So that's why we're also able to map the curve view using this ramp here. Okay, so does that make sense? What this allows you guys to do? We're able to modify the color, or we're using one attribute to modify another attribute. And this is where Houdini will come in really interesting later on the process, when you're using one attribute to control other attributes, or when you create your own attribute, animate that attribute, and have that control other attributes later on. Okay, so let me just show you what this looks like. Okay, if I add, let's say, another polywire, guys, which is something you already know, right? So polywire, plug that in, connect. Notice that it will also inherit the colors themselves, right? So we have polyradius, and then there you go. Okay, now we have that particular effect. Okay, so the reason why this is working is because the polywire also inherits the color coming from your points. In fact, it doesn't even have to be polywire. Just to show you what I mean, okay? It can be copied to points. And maybe I'll use a cube or a sphere. And maybe make this smaller. So see, guys, it can be a sphere, right? We're copying it to points, and now we have something like that. Okay, so notice that it does inherit the colors you have on your points. Okay, so relatively, I guess, straightforward stuff. Now let's expand this knowledge a bit further. Okay, so what do I mean by that? Guys, we know that we can map it to color, but there's actually a lot of things, additional things we can do. Okay, let's have a look at the polywire. Okay, because notice that we have one issue with the polywire. If you have a look at the polywire, notice that the wire radius is always consistent, meaning it's always the same value. So the reason is it's set to constant, right? But you can change this. You can actually specify an attribute to control that. Okay, now the default attribute is p-scale, but you can definitely just use curve view. And notice what happens. We have something like that. So the reason why you have something like this is obvious, right? Curve view, if you guys remember, at the start of your curve, it's 0, but at the end, it's 1. Remember? The start of your curve, which is in the bottom, it's 0. The end is 1. Okay? So if you have a look at that, see? 0 and 1. Okay? So you're getting this effect because, again, if I just expand this a bit more, okay, you're getting this effect obviously because curve view is 0 here, so it's really small, so it changes the radius to 0, and then all the way up here it's 1 because you again, it's just multiplying the radius is specified here with value of 1. That's why you're getting that effect. Okay, now this is all good. The problem is, see, it's not really controllable. Well, it can, but it's what I'll do is I'll actually just use another attribute. I'm going to use curve view to control another attribute. So what I'll do, guys, I'll do something different. Okay, instead of using curve view, I'm going to introduce another attribute here, and I'll do that by adding what we always used, what we've been using in the past, called attribute adjust color. Sorry, attribute adjust float. So I'll just remove, we already have color here. Okay, and we use curve view to modify the color. But this one, guys, I'm going to use curve view to modify p-scale. Okay, so what I'll do is I'll just use p-scale here. And then that, it doesn't even have to be p-scale. You can call what, I'll show you later on. It can be anything, right? But I'll just use p-scale here, guys. Okay, so I'm going to use p-scale here, but notice that p-scale is currently 0. I'll change this. I'm going to remap an attribute. The attribute I'm remapping, guys, is, see, you can see it here. The attribute I'm remapping or using is curve view. Remember, start of the curve 0, end of the curve is 1. So what I can do is I can now remap this. I can do it totally differently. I can have it start big, and then at the end of curve view, or when the curve view is 1, I have it small. In fact, I can even do it like this. Okay, so make that bigger and the starting and the end point bigger. In fact, I can even do it like this. Okay, so it starts off really big, and then it tapers down, and then it goes back up. Okay, and then maybe taper down. Okay, so notice what happens. I have something like that now. Okay, so the reason why this is the case is because we remapped, remember, curve view bottom, tip. We're remapping the value. So this is the bottom, this is the tip or the top, and then we're just modifying the p-scale parameter. So if you don't believe me, have a look at p-scale. So see, notice that we have, there you go. So see, these are the start curves. So they start off big, and then they taper down, and then they go big again with the value of 2. So that's why we're getting that effect. Okay. Now the color is controlled by this, but see, you have something like that. Now let's see the polywire now, guys. You can actually see that it did work. Okay, we're able to generate that effect. In fact, just to show you what I mean, we can even modify. Maybe I'll add an attribute adjust. So attribute noise, and maybe I'll add a noise to the position. So see, guys, I'll add the noise on that position, and then I'll hit play, and then maybe I'll have some animation there. Okay, so if I have a look at polywire, then I get something like that. And maybe I'll just lower down the pulse duration, and it creates that effect. Okay, I might need to increase the number of points just to make it a bit more interesting. But again, we're able to do some, I guess some really interesting stuff with this. Okay, so what this means, guys, is I might need to go in and then modify. Maybe the amplitude is a bit too big. So see, and then maybe I'll just modify the element size. And then let's see if I hit play, it gives me some more interesting results. Okay, and I guess I have something like that. Okay, so is this making sense so far in terms of what we're able to do? Um, that's poly wire. So let's have a look at from a logical perspective, right? What we're doing. Okay, so we started off with a line. We resampled it, right? So we resampled again. Really important. If you don't have that curve view activated, it won't work, because again, if if it's off, that means you don't have the attribute that we need, right? But if you have that activated, now you can use it to manipulate things like color, scale, and then add to your polywire. So there you go. So make sure that's active. See? And now that's working. Okay. Now, other things you can do with this. Okay. So again, other things you can do with this particular effect. So let's just have a look. This is where grouping will come in. Okay, there you go. So this is where grouping will come in, guys. Okay, so how you can manipulate, or you can also use the grouping to be able to, you can, I guess, group objects based off attributes. And I'll show you why that's important. Okay, so let's start off with something simple. Let's start with a color. Okay, what if you don't really want to change the color on the tips or maybe on the base? Maybe you just want to change the color on the middle. Remember that you can actually create a group, right? So again, with that group, you can specify uh, what components or what objects or what points will be affected by that attribute adjust color. The problem is you need to create a group. But I know that I have my resample node there. Know I have curve view. What I can do, guys, is I can create a group based off my curve view. So I'll create a group. Okay. Now, I can manually add that in, but what I'll do is I'll actually access the attribute itself. So how do you access the attribute? I will just type in under base group here, and I'll give it a name. It's called group 1, so that's fine. Base group, guys, I'm going to plug in a simple expression. I'll just call that attribute. The attribute is curve view. So I'll just put in at curve view. So basically what you're doing is you're telling Houdini, hey, curve view attribute, if you're, let's say, greater than 0.9 or greater than 0.8, be part of this group. So let's have a look at that. Okay. So again, this is going to be a point group, guys. So what I'm saying is if curve view is greater than 8, plug that into this group. Now you can see this if you actually go to points, and let's see if I can activate this. So there you go. So see, guys, I'll press 9 so you can actually see that. You don't have to, but if I press 9, see, group 1, those are the points that are part of group 1. So those are the points that have a curve view attribute greater than 0.9. So basically these ones here. Okay? So they have a point attribute, a curve view attribute roughly greater than 0.9 or 0.8, sorry. So 0.8, it's this one, this one, this one, this one, this one, this one. So it's probably around 5. And that's exactly what we did here. We put all those points in that group 1. Okay? So what does this mean, guys? Since they're already part of that group, I can now specify under my attribute adjust color, I can tell Houdini, you know what? Just do it on group 1. And notice what happens. It modified group 1, but it didn't modify everything else. Okay? So it adjusted group 1, but not the rest of the objects there. Okay? Or I can even specify it, maybe curve view is between, I don't know, 0.2 to 0.8. Let's see if that works. So 0.2 to 0.8. So equal to 0.2. Let's see. Not sure, I don't remember if I need equal. I'll just verify later on, guys. But if you want a range, I think it's not sure if it's like that or if it's 0.2 curve you at 0.2 to 0.8. Again, I'll verify later, but for now, I'll just use greater than or less than. So for example, at curve view, it's not brackets for this. I just need to check because sometimes it's different in different contexts. But for this one, I'll try it. So zero point 0.2 to 0 0.8. Let's see if that works. See, doesn't work. If I remember, it's not brackets as well. It's weird sometimes. So I'll just verify later on. But for the meantime, I'll just use at curve view. Um, let's say um, less than 0.3. Okay, so let's see what that looks like. So see, it's less than 0.3. It uses that. And then we have the color there. So there you go. Okay, so now I have something like this now. Okay, so there you go, right? So that's useful, right? So the reason why this might be useful, guys, okay? So I'll just show you guys, okay? What if you add something like, instead of color, what if you add something like a noise? You want to move, let's say, the points, okay? So if I add, let's say, an attribute adjust or attribute noise. So an attribute noise adds a noise on a specific attribute, let's say position, so not color. And let's say I'll just add, and maybe I'll lower the, and then maybe I have that zero centered, and then maybe I'll just have it like this, okay? And maybe increase that there. Okay, so I'll have that animated, guys. So if I hit play, 0.2, okay? So if I hit play, I get something like this, okay? Now that's all good, right? Now you can modify, let's say, things like element size, and then I can even turn off the fractal, so it's none. So it's a bit more, I guess, interesting or less noisy. So I have something like that, okay? And maybe I'll change the amplitude. So maybe something like that, guys, okay? Now, what if I actually just want the noise to affect the top bits? Currently, it's affecting everything. So see, it's affecting the base, it's affecting the top bit. But what if I just want to have it affect the top bit? This is where your group comes in, okay? So remember, we did a group for everything, let's say above, greater than 0.5, okay? So anything above 0.5 U, it's putting it in a group. So what we can do is we can now just isolate this attribute noise and then just have it work on group 1. And notice what happens. The tip isn't, well, the base isn't moving, but it's only the tip that's moving. Okay? And that's really useful, right? Because now you can isolate procedurally points that you want to target. Now we can easily change that. Okay? I remember range, you can do it. I just need to remember the particular so maybe point greater than 0.2. See, guys, totally different, right? 0.2, now you have it like this. Or you know what? Maybe you group it, maybe greater than 0.8. And notice now it's only affecting the really upper tip of it. Okay? So again, what we're able to do is we're able to use, let's say, simple grouping. And on top of that, we're also able to use things like attribute manipulation to create various types of effects. Okay? So this goes with, let's say, your color, but it can go to things like, noise. It can go into things like, p scale and all of that stuff. So is this relatively clear for everyone? Just checking. Okay. So that's right. We're using curve view, but curve view again. I'm just trying to look for a range. I just need to remember. Let's say point range Houdini. So let me just have a quick look. Again, I'll put that worst case scenario. I'll just put that in the chat later on. But for the meantime, we'll just have it like this. Okay. Okay. So with this said, guys, okay, we already have that attribute noise, and let's say greater than 0.3. Okay. So we have, I guess, something like this. Again, needless to say, right? Um, if you use things like, so let's have a look at, let's try expanding this. Let's say I'll use, let's say, a grid. Okay, so remember with a grid, I can do a copy to points. And with that copy to points, I'll just use, let's say, this one. Okay, so what I can do is, maybe I'll do the group afterwards. So basically what's happening is I'm copying to points, and maybe I'll just change this to, let's say, uh, all good. No worries, Keith. Again, everything's recorded. Okay, so I have something like that. Okay, so guys, I have something like that, and I just copied to points there. I grouped everything above. So again, I grouped everything with a curve view of greater than 0.3, so you can actually see that. So see, and then I just added an attribute noise on top of that. Okay, so notice what happens there. Since the attribute noise is so let's see, that's this one first. So if I hit play, notice now that I get something like that. Okay, so attribute noise, which part of the attribute noise is tricky? So make sure in your attribute noise you specify the group, right? Because if you don't have a group, so if you don't specify a group there, it just does it on everything. So see, it does it on everything. But if you do specify a group there, then it's only doing it on that particular group. The creation of the group, a bit tricky. So with the creation of the group there, make sure it's points group, because if you have it at primitives, it won't work. So if your group type is primitives, it probably won't work. You have to make sure it's points, because you're basically using points. The line itself doesn't have primitives, it's using points. And we're using curve view. Now you have to make sure that you actually have a curve view attribute. So with your line, we resampled it because you need that curve view attribute. Otherwise, if you don't have that attribute, you won't be able to access it. So make sure you have that attribute. Okay, so without this copy to points, so to avoid the confusion. So without this copy to points, right, basically what's happening is something like this. Okay, so basically what's happening is you started off with a line, right? We resampled it, so we have more points and we can introduce that curve view attribute. Then we just added a noise on top of that. Okay, so start with something like this. Start with something simple first. Okay, so we just added a noise on top of that. So see, we just removed the group. And then we have something like that. To animate the noise, you just need to make sure it's animated, right? Now, the thing is, that's not necessarily what I want, right? I just want perhaps the tip. So the thing is, with all your noises there and with most of the nodes inside Houdini, you can specify a group and isolate what you want to target. So I'm going to use that particular idea. So what I did was I created a group in between before it hits the attribute noise. You don't want to do it after the attribute noise because the attribute noise needs that group. So we need to do it before the attribute noise. So I created that group, and basically I just, so I created the group and then added that in. Okay, the group type is points, and you just need to make sure you give it a name, right? Or maybe group one, just take note of the name. And then we're going to access the attribute. The attribute is curve view. Make sure you're following the same spelling, and then if it's all lowercase, then make sure it's all lowercase. So we're telling Houdini @curve view greater than 0.4. So if it's greater than 0.4, if the curve view attribute of a point is greater than 0.4, plug that into group 1. And what we can do is we can now isolate, tell Houdini that we want to work only with group 1. And notice what happens. It's only doing it on the tip. And the reason why it's doing it only in that area is because the curve view attribute here on the bottom is less than 0.4. Remember, if it's the group is basically grouping all points that are greater than 0.4, and then we have the attribute noise manipulating anything within that group. So anything outside that group, so those are the values of 0.4 or less, it's not affecting it, and that's exactly what it's doing. Okay, so does that make sense for everyone? So just checking with everyone from Zachary, Will, Tianzu, Samuel, Mikael, Jordan, Jake, Danny, is that relatively clear in terms of what we're doing? Right? Okay. Okay, great. Yeah, it has to be uppercase. Okay? Okay, so with that said, guys, what I did after that was just really an extension. Really? So for example, this one, see, I just did a copy to points. So after I resampled the line, I just copied it to the individual points there. But the orientation is wrong, so I'll just change it back to 1 there. So it's now pointing up. Okay? So this is all good. But what I did on top of that is, see, if you have a look at this one, and let me just close this. See, we have that. And now, if you have a look, we have a lot of curve view attributes there. Okay, depending on the number of duplicates you have. What I did was I just grouped everything, again, with a curve view attribute of above 0.4. So what's inside that group, if you have a look, are those points there. So see, notice that those points there. See, not the base. And then I just added an attribute noise afterwards. And now I have something like that. See? So now we're able to create some really interesting effects. Now, some of you might say, can I just have done that? I'll show you guys why this is different to doing something like this. Okay? If you did this one, okay? So what do I mean by that? If you did this and then copied to points afterwards, yikes. So I'll just show you guys after I restart, but it's going to be different, right? It's different from creating the noise then duplicating it, because what happens is the noise and the movement will be exactly the same for every single one of them. Okay, so again, it will be the same for every single one of them. Hopefully it's there. No, not that one. So I probably won't do it again, but all I'm saying is if you did the noise, then you copy to points, every single one of them will have exactly the same movement, and that's different from what we did later, where what we did earlier, where every single one of them has different movements because it's using a world noise. Okay, so I guess hopefully I can just do it really fast. So I'll just show you what I mean by that. So here, 0, 1, and then we do a copy to points. And then we just do a grid. And then, so see, we did something like that. And then we just resampled it. So we did a resample. So again, the resample allows us to introduce that curve view attribute. And that's important because it gives us the start and the end of the curve. And then I make this a bit longer. So there you go. So what I'm saying, guys, is if you did the noise here, and then you used position, and then you copy the points afterwards, can you guys see that? Everyone will have the same movement. So see? And let me just turn on animation and then activate real time. See? So can you guys see that? what we did, again, from a logical perspective, right? We resampled it and we added a noise on just that one object. Then we copied it into individual points. So what happens is it will have exactly the same movement. Okay, maybe that's something you want, maybe it's not. But if you want something else, if you want a totally different movement, you do it after. Okay, because see, the noise will be different because the noise is basically world noise. So wherever you are in world space or in 3D space, the noise will be slightly different. And now we have something like that. Okay, so that's totally different from something we had earlier. So good question from Samuel. Yes, you can. Okay, not using, let's see. So basically, Samuel wants to manipulate amplitude. You a couple of ways you can do that. You can just put at, then plug in curve u, but we don't really have curve u there. So you can technically do that using some sort of expression, but I'll show you better techniques next week rather than doing it this way. I don't really want to introduce expressions too much. I prefer just doing nodes, so it's easier to plug in. Otherwise, it gets a bit trickier because the problem you have with amplitude is vector x, y, and z, but our curve view is float. So you technically need to convert the float into a vector first before you can plug it into the amplitude. So again, the amplitude is x, y, and z, right? But the float is, but curve view is a float, just one value. So you have to convert that into a vector first, then put it in here. But there's easier techniques than putting an expression there, especially if some of you haven't used expressions before. Okay, but there are processes to do that. Okay, so we'll have a look at that, later on. Okay, so with that said, guys, let's just have a look at a few more other techniques. So we know how to resample and we know how to use it. We know how to use those attributes to control other attributes, and that's going to really help us a lot, moving forwards. And maybe I'll just add one more. You know what? I might just skip this because it might be a bit. I guess just a tip, right? I'll just show you guys. So I'm just going to create a box and I'll just make it bigger. Okay. And I'll just add an attribute noise. Or you know what? I'll just use position. Because you can definitely use trails as well. Okay. And basically this allows you to, I'll just animate this and then increase the amplitude significantly and maybe increase the number of divisions. Let's say 4, 4, 4. And then let's see what that looks like. So I guess, something like that, and maybe increase the amplitude. Okay. So another way of procedurally generating geometry is using trails. So basically with trails, and again, you're able to generate multiple points from individual points. So what we can do is, let's see. So we can connect as polygons. We're going to create trails out of that, similar to what we have here. And then we're going to increase the trails. The problem with that is it's connecting it. I'm just looking for, there you go. So we're able to generate a trail of points, right? The only problem we have is since we started off with polygons, guys, it's also generating polygons here. Okay. But yes, lots of the different things you can do with this. But what I'll do, guys, is with this box, right? I'm going to just use a special node called add. And the add node allows us to do a couple of things. It allows us to delete the geometry, but just keep the points. So what that means is if I add an add node, it basically removes the geometry, but it's able to keep our points. Okay, so notice now that this is our original geometry. We added an add node. We turned on delete geometry, but keep points. And then we activate that. And then once we turn on attribute noise, we're able to generate, I guess, something like this. Okay, now if I add a trail node, it's still giving me the same thing. Let me just, There you go. I'll just have it as preserve original. Okay, so with preserve original, guys, notice that I'm able to generate those trails now. Okay, so it does give me some really interesting effects. Okay, now on top of that, we can use a copy to points, and maybe I'll just use a sphere or a cube, and then I'll just use that as my copy, and then let's activate that. Okay, so I'm able to generate something like that. Okay, so again, different ways of generating stuff, right? So we're able to create a trail, and then from the trail, it's basically points, and then we're able to do that. Okay, now we can even convert that trail into lines, but I'll probably just skip it for now because we were going to introduce a bit more stuff. Maybe I'll just cover it next week. But what I want to do first is just to make sure that you guys are clear, I guess. So are these topics clear for everyone? So do you know how to merge? Do you know how to copy an instance points and manipulate attributes of those instances and generate some, different things using color, p-scale, and all of that stuff? And are you comfortable with lines as well? So just checking if those three things are clear for everyone here. So just checking with Danny, Jake, Jordan, Mikael, Samuel, Tianzu, Will, Zachary. Making sense? Okay. So just those three things, right? That's right. So that's why we have the recording. So you can, with those three things, guys, you should be able to generate or you should be able to recreate this, but you just need to know how to render this properly. Okay. Okay. So let's just have a look at basic rendering. Okay. We still have time, so I think we're good. So I don't really want to extend the class too much. That's good. Okay, so yeah, it's with Houdini, it's going to be a lot of experimentation. So you guys really need to, explore and then play around with it a bit more. Okay. So you guys know at this stage how to render, right? Our rendering technique is just using this button. It allows us to create a flipbook, and that's okay. That gives us some acceptable results. But if you really want to expand your knowledge or your quality of rendering, you have to use an advanced renderer. So something like RenderMan, something like Arnold, something like V-Ray, um, uh, hardware renderers, Redshift, all of that. So those are high-end renderers. Inside Houdini, we have a high-end renderer called Karma. It's pretty good. It's hardware based. So we're going to explore how to render using Karma. Okay. Now, to really see this, let's just perhaps create a really simple piece of, kinetic sculpture. Okay, maybe I'll create some sort of wave sculpture. Okay, so what I'll do, guys, I'm going to create a grid. Okay, and you can do this as well, just to practice. So I have that grid there. I'm going to increase the number of points there, and then I have something like that. Right, it's relatively straightforward stuff. Now, if you don't want that even guys, so see, sometimes you don't want that even. There's a simple node that allows you to just do that. So what I'll do, guys, is maybe I'll just use a simple node called remesh. There you go. So with the remesh node, notice that it allows you to change the target size. It's basically remeshing your geometry just to give you, triangles similar to this, because sometimes you don't want them evenly distributed like squares on your surface. So just remeshing that allows you to create something like that. And that might be interesting, right? Now, before we continue, just a quick thing, right? The polywire node actually works not only with curves, but also with edges. And just to prove my point, if you have, let's say, a grid and you added a polywire node, so polywire, right? Notice what happens. See, you get that, right? So the polywire node not only works on curves, it also works on edges. Okay, so similar with the remesh. And let me just adjust our wire radius to, let's say, 0.05. So if I plug that into the remesh, see guys, that's that, right? So basically it's just converting, not really converting, I say converting, but it's not really converting it. It's just creating a wire or a piece of geometry for all of those edges, right? So what this means, guys, is, for example, if you have a sphere, right? And with that sphere, perhaps I'll make that polygon, and maybe I'll increase the number of the frequency there, and maybe increase the uniform scale. So if I just simply add a polywire node on it, notice that I get something like that. Okay, so again, it's just using the edges, right? So just an extra thing. Anyway, going back here, I remeshed it so we have something like this. Okay, and I just like the distribution a bit more. So what I can do on top of that is I'm going to deform this. Now I'm not going to deform, I'm going to deform it in a different way. Okay, I'm going to deform it using a special deformation tool. It's under deform. And the special deformation tool is you can either use ripple or you can use waves. I'll just use waves. Okay, so I'll just use waves. And notice what happens. It does, I'll click on it. Basically, I clicked on remesh and then click on waves. And notice what happens. It does a couple of things. It added this ocean evaluate node. And basically, this allows us to deform an object based off some mathematics defined by your ocean spectrum. So I'll do that one more time. Okay. So you don't have to generate it manually. Basically, you're inside your geometry level. This grid, I'll just click on, let's say, this wave. That's under deform. So waves, and notice that I'm able to generate that. Now, to control what you're getting here, have a look at the ocean spectrum, because you have things like, I don't know, the speed of the wave. You have the grid size. You have amplitude that allows you to change the scaling of the wave there. And then you also have other things like swell and all of that, direction and stuff. But if I hit play, guys, and I'll just turn on real-time toggle, I get something like that. Okay, so again, the ocean spectrum allows you to manipulate the properties of the wave, but it's the ocean evaluate node that actually does the visualization and the actual deforming for you. This is really just the math and the properties involved, but this is the one doing the deformation and the visualization. But again, this one, guys, see, you have things like grid size, so you can make that smaller, or make it bigger, and then you do have speed, so it does allow you to change some of those things there. Okay, so is this making sense so far in terms of what that does? Maybe I'll lower down the grid size. There you go. So I'll just get better looking waves there. Okay, so making sense so far. This ocean evaluate node, guys, what we're able to do though is it allows us to also create attributes, right? So we only have position attributes there. So basically it's manipulating the position based off that wave. But notice, guys, you actually have cusp attribute. And what this cusp attribute allows you to do, it generates a cusp attribute there that allows you to specify the lowest part of your wave and the highest part of your wave. So basically, if it's in the lowest part, it will probably give it a negative value, right? But if it's in the highest part, it's going to give it a positive value. So if you hit play, basically it's animating because you have waves. So the points are going to a higher cusp to a lower cusp. So it's basically going up the spectrum and down the spectrum. That's why you see it animating, right? So that's why you're seeing something like that, okay? Now, this is all good, but what we can do is we can use that attribute, right? We can use that attribute to change the color of the object. You can actually do it here, but I prefer doing it after. So what I'm doing, guys, remember, we can use an attribute adjust color. Remember that? So attribute adjust color, and then I'll plug that in. And then remember, we're going to change color for every single point, and then we're going to remap an attribute. The attribute we're mapping, guys, remember, it's called cusp. So lowercase u, C-U-S-P. So I'll change it here, cusp. And again, basically this is the lowest point of your spectrum, highest point of your spectrum. And maybe what I'll do is I'll just use, I don't know, Inferno. And maybe I'll just remove some of these points here. So maybe something like that. I'll increase the number of points so it just gives me more points to work with. And let's see what that looks like. Guys, sometimes the visualization isn't working. So sometimes it's always a good idea to install labs. So basically you can install labs by going under, I think here, there should be, um, or have a look at your Houdini installer or Houdini launcher, because you can install labs. I'll show you why that's important. So see guys, this is your Houdini launcher. You can install labs there and then install the packages. So you have labs. Because with labs, you have the ability to reset the viewport. Sometimes you need that. But anyway, you have that custom attribute. And what it's able to do, guys, is it's able to modify the color there. Now, just take note, it thinks that your cusp goes from 0 to 1, but it doesn't. Remember, it sometimes goes negative and sometimes goes positive. So this range is not correct. But luckily for you guys, it has compute range. So you just click on that. So see, now we have something a bit more accurate. So it goes from -3 to +7. And now perhaps we can modify some of that stuff. So see guys, notice what happens if I hit play. I get something like that. Okay, so what we're doing really is we're just using that cusp attribute and plugging it into our color. And now we're able to generate that effect. In fact, let me just increase the number, the grid there. So remesh, maybe a lower size. Oops, maybe not that low. Hopefully it doesn't crash. There you go. Okay, so see guys, now I have something like that now. Okay, so all good. So what else can we do? Okay, we can do a copy to points, right? We can do a copy to points, and then maybe we can use a cube, right? And then we just use a cube, copy that, and then make that cube smaller, and then let's see what that looks like. Okay, so with that, guys, see, we can use a cube, and then we can uniformly scale that. Maybe I'll lower down the number of points there. And let's see what that looks like. Okay, so if I hit play, I get something like that. So basically what we're doing is we're just duplicating, copying points there. So see, notice now they have cubes, and then the cubes are basically moving together with our wave, right? So we're generating that effect. Now that actually looks pretty interesting as well. Now I take it a step further because I know I can also manipulate p-scale, right? Remember, I can use attribute adjust float to add, let's say, something like p-scale. So maybe float remap attribute. I'll stop it, and maybe just in case it crashes, I'll just sample. Okay. Again, I'm going to use the cusp attribute here. Remember, cusp goes down and up. And now I'm using it, I'm plugging it into the p-scale. So basically, again, compute range, so we know what the starting point is and what the end point is. And see, guys, basically what I'm doing is I'm telling Houdini, you know what? If you're up on the wave, increase the scale of the points. So basically, scale of the boxes. So make it small when it's below the spectrum. Make it big if it's high above the wave. So notice now that you get that effect now. See? So I have something like that. Now, I'm going to show you how to plug that into illumination as well. But let's have a look at the rendering at this stage. But is this relatively clear for everyone in terms of how I did this? So we started off with a grid. We remeshed it, right? We added the deform waves, and this gave us the ocean spectrum and the ocean evaluate. But we activated the cusp attribute that allows us to visualize or document or put into data the highest point of the wave and the lowest point of the wave. And then we plug that and remap that cusp attribute to control the color. And then we also use that same cusp attribute to control the scaling of those individual points. And now when we did a copy to points, we're able to generate that. Okay. So is this clear at least with regards to You need to obviously do it, but is the logic in this clear for everyone? So just checking. If from Zachary to Will to Tianzu all the way to Danny, is the logic relatively clear in terms of what we're doing? Okay. So the reason why I'm doing this is because we're going to start having a look at rendering, okay? And then I'll just save that just in case it crashes, okay? Because the thing with rendering, guys, is we need to understand a couple of things, right? We need a 3D mesh, and we already have that. We'll have a look at how to generate the camera, okay? So I'm going to create a camera by just going under lights and cameras. And what I'll do is I'll just drag that camera directly there. Or you know what? You don't even have to. You just click on camera and it automatically allows you to generate the camera wherever your view is. Guys, remember to reposition the camera. Always make sure to lock it. And I'm doing this fast because we've done this last week. So lock it and then I'll reposition that maybe, you know, something like that. Okay. So now I have, I guess, that particular look there. So that's good, okay? But I'm not going to stop there because what you can do with a camera, and let me just show you what I mean. I'll turn off the lock so I can rotate the camera view and we can see the camera there. Because what you can do with a camera, guys, is you can activate the handle here. So you can see that. And this allows you to generate and see where the target of that camera is. Basically, with the camera, if you have a look and select that in your object level, you have a look at it, notice that it has sampling. Basically, it has a focus distance. And the focus distance is specified by this value here. But it can also be manipulated by just selecting your camera in your perspective view, activating this handle, and notice that when you press U, or just select this one, the manipulator, notice that you can change the target distance to anywhere we want. So basically, this is the distance, or this is the point of focus of this camera. So I want to put the focus of that camera, you know, somewhere there. Okay. So it's probably around 6.9. Again, it's 6.9 here, but it doesn't really matter what value it is. The important thing is you know how to manipulate where the focus point is by just clicking on the camera and clicking on this point here, the handle. And then we're specifying where it's actually pointing. Now, if you right click on the manipulator, guys, you can actually change the focus and the frustum as well. Meaning, if you go to the focus handle, see, you're getting a totally different visualization. So again, right click and then focus handle. You can access it using Z, I think. But we're looking at this, right click there, and then we go focus handle, which is Z. But see, guys, this is basically the area where it's in focus. Okay, so basically anything within those two arrows, it will be in focus. Anything outside those arrows will be out of focus. So I'll make that focus. So I'll have a small depth of field. So it's only focusing on a small area. I'll make that very narrow like this. Okay, you don't even have to do it yet. I'll just show you the actual effect later on the process. Okay, but all I'm saying is you are able to change the focus distance, and you're also able to change which parts of your image will have full focus and which parts of the scene will be out of focus by, again, going to your perspective view, selecting your camera, going to your manipulator, and then right clicking on that manipulator. You can go to the focus handle or the orientation handle, and then you can specify the area of focus there. Okay, so at this stage, we have a little bit of additional knowledge with regards to 3 cameras. We know that we have the piece of geometry there. Let's just have a look at lights afterwards. Okay, so lights, guys, I'll do something really simple with lights. I'll just add, you know what? I'll just add a simple area light and I'll just plug that in there. And then with that area light, I'll just reposition that somewhere there and maybe rotate that a little bit and then make that a bit bigger. All good. So with that, I'll make that slightly bigger. Let's say 3 and 2, and then increase the exposure a little bit. So maybe something like that. Okay. Now we can add more lights if you want. So maybe I'll duplicate that light, reposition that here, and then rotate that. Okay. And let's see what that looks like. So maybe reposition that somewhere there, and maybe this one. And let's see what that looks like with my camera. Okay, there you go. Okay, great. So is that relatively clear in terms of the mesh? Because the next 2 things are going to be the harder parts. But is this clear for everyone in terms of how, when you're dealing with karma, how you can generate the geometry? So it's just straightforward. but what you can do with the camera and what you can do with the lights. So with the lights, something simple, an area light is fine, but I'm able to add that in. Okay, so let's have a look at how you can actually generate materials. So this is the tricky bit when when it comes to Karma. Okay, because Karma uses an advanced, it's getting popular now. It's using standard surfaces, which is getting popular with virtual reality and with also with making things consistent from one studio to another studio, especially when you're using different types of renderers. So Material X is quite popular. Okay, so what we're using Material X for our materials or shaders. So how do we do it? Okay, the first thing you need to do, guys, is we're going to create our Material X shader. So again, a Material X shader is like a shader that you're familiar with. You know, it might be a blend, it might be a physical PBR shader. But the way to do that inside Houdini is you go to your material context. So tricky bit, go to your material context here, right? So this is your material. This is where you create connections for your material. And what we're looking for, again, it's not object, it's materials. And what we're looking for here, guys, is we're looking for standard surface, meaning look for material X, and under PBR, we're looking for MTLX standard surface. So this one. In fact, you can just type it in. So press tab, MTLX standard surface. So I'll do that one more time. So again, material palette, right? Material context. So this is where we create connections and we create different types of material effects. Press tab, and we're going for material X, and we're going for PBR, and then material X standard surface. So again, material X is the popular, it's getting popular. It's allows us to transition between, let's say, using something like V-Ray, and we can easily transition to Arnold, to RenderMan, if they're all using the same Material X shader. Okay, all good. So I'll just go Material X standard surface, like so. And with that Material X standard surface, guys, we just give it a name. So let's say matte wave. Okay. And then with that matte wave, I'm going to assign that to our object. So how do you assign a material to the object? So we created that matte wave. It has things like base color, specularity, transmission, all of that stuff. But we want to plug that into our surface. So what do we need to do, guys? We need to go to our geometry, which is our grid object here. Remember, copy to points. We're going to add a special node afterwards, right? We're going to add a special node called Material X, and we're going to plug that in. So again, we're adding a special node after called material. So this allows us to assign a material to an object. So plug that in, make sure it's visible, guys. And the material we're looking for is, remember, under matte, it's the matte wave. Okay, so again, it's under materials here, choose operator, matte wave, hit accept. Now don't panic if you lose the color, because it's just, I guess, not really a bug. It's a problem. We won't be able to see it properly yet, but we know that it is assigned. Okay, so see, guys, it is assigned. Okay, so making sense so far in terms of how we create and how we assign a material. Those are important things, right? We create the material inside the material context. It has to be as MTLX standard surface, and then on top of that, we assign the material by going inside our geometry and then just adding a material node and then specifying what material we want to assign to that geometry. So are those two things clear for everyone? So just checking if that's clear from Danny to Zachary. Relatively clear. Again, we create it in our material level and we assign it in our object level here. Now we're almost done. We just need to make sure that Houdini uses all of those attributes that we have. So what does this mean, guys? So notice that under our base color, right? So under our material, I'm currently in material palette. We can specify things like color. We can make it blue. We can make it all of that. But that's not really what we want, right? What we want is to grab the color coming from our geometry. We actually want to use the attributes to control our materials. So again, we don't necessarily want to assign the material colors ourselves. We don't want to necessarily assign the emission ourselves. We don't want to necessarily assign things like sheen or a subsurface ourselves. We want to use attributes to control them. So how do you do that? Inside our material wave, guys, or inside our material context, I'm going to grab the geometry color. And the way to do that is under Material X. we're going to go under geometric. We're going to drag the geometry color. So again, material X, geometric, we're grabbing the geometry color of the object. So grabbing the geometry color of the object. Now the issue is, which is weird, it's always set to float, which is weird. It's supposed to be color, right? So we're going to change it to color. So basically, guys, we're going to connect this to our base color. So we're telling Houdini, you know what? This is going to be our base color. Plug it there. Okay? So again, base color, plug it directly there. So again, we just need to make sure that it's set to color and we're plugging it to our base color, right? So relatively straightforward stuff. Guys, we don't really need the color specified there, but that should be fine. Okay, so we already specified it like that. Guys, we can even assign that to other things. We can assign that to, let's say, things like emission, right? So for example, emission color, we can use exactly the same color for emission color there. So see? So again, we can assign the emission color or the geometric color directly to our emission color. You can even assign that to sheen color if you want. So you can assign it to, let's say, sheen color, or you can assign that to coat color. But all I'm saying is you can assign it to other colors as well, not just base color. You can also assign that to emission, right? Now, the thing is, I can also assign other attributes to those particular parameters. So let's say I want to control the emission color based off, let's say, the cusp or the scaling or the p-scale of those objects here. Okay, so what if I want to assign, or I want to assign the p-scale and plug that into emission. So I want the p-scale to control the emission. Similar stuff. I'll go material X and I'll go geometric. But this time, guys, instead of geometric color, I'm going to grab the property value. So for the property value here, remember, we're going to be using p-scale. Remember, p-scale is something Houdini understands. We're actually using p-scale to control the scaling of those individual points there. So I'm using it. So what this means is the bigger the p-scale, the more illuminated it gets. So I'm going to plug that directly there under emission. Okay? So with that done, guys, I'm going to save this just in case it crashes. Let's see what this looks like rendered out. Okay? So again, I plugged in the geometry color to the different colors there, including emission color and also base color. And I plugged in p-scale to control the emission of our material. And let's see what this looks like. I'm going to go to out because we need to specify the renderer. The renderer we're looking for is, again, under out. The renderer we're looking for is karma. So again, under our out context, we're looking for render karma. Okay? So with that render karma, guys, notice now that we have rendering engine CPU, but I have a fast GPU, so I'll just use XPU. So if you have a fast GPU, just use XPU. That should be fine. I'll just save this just in case it crashes. But see, guys, I already have my camera there. That's good. And let's see what this looks like. So I'm going to turn on camera viewport, and let's see what this looks like rendered out. Notice, guys, that we are getting something like this now. Okay? I'm also getting a really shallow depth of field. Not a big fan of that, but we're seeing, a really shallow focus, right? But we're also seeing a few things. We're seeing the cameras and we're seeing the lights. I'll just temporarily remove that. It doesn't really affect our render, our final render, but see, I'm able to just remove that. So we're just focusing on that. Okay? So I'm happy. Notice that we have some illumination there. We have some depth of field. What I do want to do is maybe modify the depth of field a bit more. Meaning with my camera, guys, I might need to just change my f-stop. So this is basically the focus. Or what's in focus, what's out of focus. I'll increase that. So there you go. I'll increase that. And it just gives me a better focus area. So see, this area here is really in focus. And then maybe I'll increase this a bit more. Okay, there you go. So now I have something like that, guys. Notice how fast it is, right? Probably took us a few seconds to just render one image. Okay? Now what I'll do is I'm going to just have a quick look at some of my settings here. You can use CPU, but I'll just use XPU because it's relatively fast. So what I'll do is I'll just use XPU, guys, and then I'll just do one other thing. I'll go to image outputs, and I'll just go to filters because I just want to add a denoise filter just to clean up my render afterwards. So I'll just use the noise, and then it just removes some of the noise I'm getting there. So notice how fast that is. Okay, so we're getting a really fast result. I think I'm getting motion blur. I don't necessarily want motion blur. So I'll just turn off motion blur, guys. So see, so I'll just turn off motion blur, and now I have something like that. Okay, or you can turn on motion blur if you want, but I don't necessarily need to. I'll just turn off motion blur, and I'll just enable depth of field. Okay, so I sorry about that. So I need to enable depth of field, and then maybe I'll just change the focus distance a little bit, and then there you go. Okay, so maybe I'll just lower that down. So see, these areas are out of focus, and this area is really in focus, right? And then this is totally animatable as well, right? So if you hit play, now it's animating. I won't render it, it'll take time, but that's how you assign a material, and then that's how you specify a render. Okay, so specify a render, go to Karma, and then we specify a renderer there. Notice that we specified the camera, we specified the CPU or the GPU for rendering. Now the only issue is we need to render the entire frame sequence, right? And the way to do that, guys, is here. So we specify a frame range. We just either plug that at 240, or we just change this value here, maybe from 1 to 120. It automatically changes this. So 120. So see, or you can just right click, delete the channels, and you can just manually add that in. So maybe 120. And this is the tricky bit, specifying, I guess, the output. So I want to plug that into my jobs directory under render. And maybe I'll create a new folder there, test. So this is the folder. So we just specify the folder, and then we specify the file name. So similar to what we did last week, we just give it a name, right? My render, and then underscore $F. That's for your frame, individual frames. Give it a padding of 3, and then our file extension, guys, is .jpeg. Okay, and then hit accept. So what it does, it will render every single frame from frame 1 all the way to frame 120. It will save it under our directory there. So hopefully it's let's just set that up again. So set project. And then hit accept. So I'll just do that one more time. And then there you go. So that should be fine, right? So frame range, and then all you need to do, guys, is render that to disk. Okay, so when you render that to disk, I won't do it because it will take a bit long. Maybe it will take like 30 minutes. But see, the moment you do that, you have this, and it's rendering in the folder that you specified, just to prove my point. So it's storing it in the folder you specified. So see, under render, and then there's test. So see, guys, now you have those rendering. So this is my first render, first image, second image, and then there's 3. So notice how fast that is, and notice that you have nice depth of field, and you also have nice illumination there, based off how we discussed things. Okay, so I'll just stop this. All you need to do afterwards is to just convert that image sequence into a movie file, similar to what we did last week. Okay, so is this, again, you can watch the recording, but is this relatively clear in terms of how we did this? Okay, I'll stop this or interrupt. But again, the idea behind this, guys, is we specify a renderer. It has to be the Karma renderer. If you have a fast GPU, set this to XPU. And then on top of that, you just want to obviously do things we did earlier. That's this material 1. Okay, and then we have to specify again, we have to create the material itself. Here in the material context, remember, MTLX geometry color, it has to set to color, and then we can even grab a property value. In fact, you can even generate your own p-scale. It doesn't have to be p-scale. You can create an attribute called van or foo or whatever, and then remap the p-scale on that particular attribute and use that to control the illumination, similar to what I did. Okay, to the challenge. So your challenge for this week, and everyone watching the recording, challenge for this week is this one. recreate the sequence. Okay, in fact, I'll plug that in here. So challenge for this week 2 challenge. Okay, a couple of things here that you guys need to think about. Okay, so with regards to the breakdown, okay, notice that the tendrils are deforming. Notice that it has a wireframe core. Notice that it's also higher end rendering, meaning guys, it has depth of field and it also has a nice rendered, look, right? So it doesn't look like the rough rendering we did in the first challenge. And then it has illuminated tips. So the tips are illuminated. So you have to think about how you can create those illuminated tips. In fact, even the starting points are illuminated, but as long as the tips are illuminated, guys, take note that the tips are bigger than um, it's not the same width from the base to the tip. It's bigger at the tip, so take note of that. So it's bigger at the base, bigger at the tip, and then it's basically a gradient, right? You have a gradient color from the base all the way to the tip. The tendrils are deforming, higher level rendering. In fact, I'll share it here. And there you go. At PGW, okay, recreate this sequence. Deadline is Wednesday. Wednesday, that's October 4, I think. October 4. So try rendering in Karma. And then I'm going to share that video as well. So let's see who among you guys, or who among the two classes, or who among you guys are able to do it first. Again, have a look at that, render it. Again, if you have a relatively good machine, this will probably take 30 minutes to render. If you have, let's say, 240 frames, if you have 120 frames, that's even faster. Okay, so just take note of that. And I guess that's it. Is the challenge clear for everyone? Just checking. So the challenge clear for everyone in terms of what you need to do? Okay, great. So I'm going to stop the recording, and I'll also stop the recording here.